Hello everyone. Today we are going to look at mode of data which is called the relational model. The objective of this session, what is the structure of relational database and types of keys in relational model. A relation represents a table. As you can see in the slide here, this slide shows there is a small table which has three different columns. The first column is account number, second column is branch name, and third column is balance. In this account table, having several different rows, each rows correspond to one particular record or one particular account in this case. So the first row has a account by account number A101, branch name downtown, and balance 500. So each row in a table represent a collection of such related data value are called as an instance of the relation. The relation model concepts. The first one is relational database consists of a collection of table. All data value are atomic. No repeating groups are allowed. Then what is the attribute? Each column in a table is an attribute. The attribute are the properties to define a relation. So example for student table, the student roll number and name is an attribute of that table. Table is a relational model. Your two relations are same in the table format. It is stored along with its entities. A table has two properties, rows and columns. Rows represent records and column represent attributes. Tuple means it is a nothing but a small row of a table which contains a single record. And column means it represents a set of value for a specific attribute. In this table, you have to display the column names like S hash, S name, status and city. These are the attributes of that table. And this is the tuples. These are the rows or records. The first record is S1, Smith, status 20 and city is London. This is the first tuple like a T1. Then S2, John, status 10 and Paris. This is the second tuple like T2. So T1, T2 up to Tn is an tuples and A1, A2, A3 up to An is an attributes. That means S hash, S name, status and city. These are the attributes. It is called as a table. What is the degree of relation? The total number of attributes within the relation is called the degree of relation. The total number of attributes for this table, you have to display this table and the total number of attributes for this table is 4. So degree of that table is 4. So you have to display, this is the degree symbol. This is the degree means total 4 columns. It is the degree. This is the total number of attributes. Cardinality. That means total number of rows present in the table. So in this table, you have to see that there will be total number of rows is 5. So these 5 rows, that means this is the cardinality of this table is 5. So this is the cardinality. That means total number of rows are present in that table. Attribute domain. Every attribute has some predefined value and scope, which is known as attribute domain. So you have to display, there will be number of domains. So firstly, what is domain? Domain is a basically set of atomic value which define the space within which an attributes might obtain a value for itself. So domain is a set of values for particular column. Suppose S hash is the first column. This set of values means S1, S2, S3, S4 and S5. All these values is called as a domain. You have to see this. This is the all these columns are present. So you have to display this as a domain. This is the all set of values is domain D1. And this all set of values of S name is a domain D2. Same like that, this is the domain D3 and this is the domain D4. Domain is denoted by capital D. So the first domain means first column, it is D1. Second domain means second column, it is to D2 up to Dn. These whole all columns, it is called as in D1 cross D2 cross D3 cross D4. These all four columns or all four domains is cross product. It is called as in one table or one relation. So this is the basic structure for a relation. So what is the basic structure? The basic structure is give the set of D1, D2 up to Dn in a relation small r is a subset of capital D1 cross capital D2 cross up to capital Dn. So all cross product is collectively one relation has been present. And attributes means A1 up to An. These are the attributes where each AI is belongs to the capital Di. This is the example. Suppose one customer table have three attributes: customer name, customer street and customer city. In customer name there will be there will be values. Customer name is in John. Next customer name is Smith. Third customer name is Curie. And fourth customer name is Lindsay. So this is the customer name values. The set of all customer name means it is to be an D1 domain. And customer street values is main, north and park. This set of all street names are present in this set. And customer city is also present in this set. So when there is a R is equal to in brackets John is a customer name, there will be street name is main and there will be city is Harrison. So all these record means first row. Second row is Smith, their customer street is north and city is Ray. So this is the second row. So all these rows are collectively means it is to be in one relation. And that relation is called as in customer name cross customer street cross customer city. So cross product of these three attributes is called as in one relation. What is the attribute types? Each attributes of a relation has a name. The set of all allowed value for each attribute is called the domain of the attribute. Domain is basically it is to be required as an atomic value. So attribute value are also required to be atomic, that is individual. Atomic means it is to be a scalar, not to repeated or duplicate. The value of attribute can be account number but cannot be set of account number. The domain is said to be atomic if all its members are atomic. So firstly, what is the relational schema? A relational schema represents the name of the relation with its attribute. Suppose A1, A2 and AN are the attributes for that table. So capital R is a relation. So capital R is equal to A1, A2 up to AN is a relational schema. So relational schema represent the name of relation with its attribute. A relation schema is defined by the name of a relation. Here it shows the capital R and a list of attributes. So here it is to be shown that A1 up to AN is an attribute. So this is the name of a relation capital R. In previous example, you can see that the relation is account have three attributes: account number, branch and balance. So schema for that relational table like account is account schema is equal to in bracket account number, branch and balance. These are the three attributes. So in this example, suppose customer schema, you have to display the customer schema. It is like a capital R is equal to in brackets there will be attribute list is customer name, comma customer state, comma customer city. So these are the three attributes are present in customer schema. Suppose same the student schema, then student schema is equal to in bracket roll number, name of student and class. These are the attribute for student schema. So you have to display the schema to represent the name of relation with its attributes. So small r is a table name and capital R means it is to be in schema. So it denotes small r in bracket capital R is a relation R on the relation schema capital R. For example, customer in bracket customer underscore schema. This is the customer schema. Same account schema. In account schema is equal to in bracket account number, branch name and balance. These are the attributes are present in account schema. The properties of relational schema. The name of schema for first letter is capital. So you have to display the C for customer table. The C letter is an capital for the customer underscore schema. The name of schema, the first letter is capital. What is the instance? Instance means the current value of a relation are specified a table. So any one particular current value it is called an instance. Suppose the customer name for this customer table, the John is a one type of instance or Smith is another type of instance. Instance means it is the current value of a relation. So element T of R is a tuple. So these are the tuples like T1 in this. This tuple is T1, this T2 up to these are the